a tangent of a point when it decides to turn. So it is the turning points of a curve where we call it as maximum point or minimum point. So the gradient, you know that a differentiation is actually a representation of gradient of a curve. When you know that, you have to understand when a curve has the turning points of a curve will always have a zero gradient because the tangent will be a straight line. So for a straight line tangent, you will get dy over dx equal to 0. Okay, this concept is very important because when the question asks you to find the maximum or minimum values of a curve, always remember that the tangent will be a zero tangent where there is no inclination of the tangent. So let's see an example. So if you were asked to find the turning points of y equal to x to the power of 3 minus 9x to the power of 2 plus 12x minus 3. Okay, you're gonna have this type of curve. Okay, so the first thing that you have to do is to differentiate it. To differentiate the equations. So 3 times 2 is 6x. 3 minus 1 is 2. Minus 9 times 2, 18 x to the power of 1 plus 12. Okay, so the differentiation of dy, the differentiation of y is 6x to the power of 2. Differentiating y with respect to x, you will get these equations. So when you know that dy over dx is equal to 0, you can write the equation plus 2. Remember that the question asks us to find the coordinates of the turning points. Okay, I'm going to write down coordinates of the turning point. Coordinates of the turning points, which mean you have to find the coordinates where the curve turn. Okay, so write down 6x to the power of 2 minus 18x plus 2 equal to 0 so that you can find the value of x. Okay, you know that dy over dx is 0, so the differentiation of y is 0, so just write down. And then using factorization as usual, but first simplify this equation, and then using factorization you will get x minus 1, x minus 2 is equal to 0. So x is equal to 1 and x is equal to 2. So there are 2 points where the curve turns itself. Okay, using x equal to 1 and x equal to 2 in the equation, you will get the value of y. So first let x equal to 1, y equal to 1 to the power of 3 minus 9 1 to the power of 2 plus 12 times 1 minus 3. Okay, so calculate this, you will get 2. Then when x equal to 2, y is equal to 2 to the power of 3 minus 9 2 to the power of 2 plus 12, x is 2 minus 3. You will get 1. Hence, your answer should be written as the turning points of the curve are x1, y2 and x2, y1. Okay, these are the turning points. Under the topic of maximum and minimum values, you will also have questions that ask you to determine whether a turning point is actually a maximum or a minimum point. So this is a diagram that shows how we actually determine the gradient of a curve. So I've taken this diagram from technology2skills.com. Okay, so look at the gradient of this line here. If you have a tangent here, okay, this one, this is a positive gradient, so dy over dx will be more than 0. Okay, and then this dy over dx is equal to 0 when the tangent has no gradient, and then dy over dx is less than 0 when the curve is going downward, and then when the curve is going upward, again the gradient will have a value which is more than 0. In this case, when you could determine the value of the gradient for each tangent, you will be able to draw the curve, right? So this is the concept on how to determine whether a curve is a maximum or a curve has a maximum or a minimum value. For example, when you have y equal to x to the power of 2 minus 4x plus 7. Okay, to better understand what I mean, let's do a question. So find the coordinates of the turning points on the quadratic curve. Let's say you have a quadratic curve of y equal to x to the power of 2 minus 4x plus 7. By looking at the equation, you don't know whether the curve shape will be like this or should it be like this. Okay, so if the curve is like this, it should have a maximum turning points, maximum value of turning points, and this type of curve will have a minimum points or minimum value of turning points. What you first have to do is, of course, to differentiate the equation. X to the power of 2 is 2x minus 4. You know that along the curve, okay, along the curve, the gradient will always follow this function. Okay, the gradient will always follow the function of 2x minus 4. So how do we know the turning points of the curve? From the previous example, you know that either the maximum or a minimum point will always have a gradient of 0. Okay, the tangent will always be 0. So let dy over dx equal to 0, you will get 2x minus 4 equal to 0, and x equal to 4 over 2, which is 2. So the turning point will have a value, the coordinate of the turning point for x is 2. And then let x equal to 2 into this equation. You will get y equal to 2 to the power of 2 minus 4 times 2 plus 7 equal to 3. So the coordinates of the turning points is 2, 3. Now how do we know whether it is a maximum point or a minimum point? So in this case you have to do a simple checking. Okay, we call it as checking the nature of the point. So the point is 2, 3. How to check the nature? Tabulate a table that has 3 columns. When x is less than 2, when x is equal to 2, and also when x is more than 2. We are now trying to figure out what happened to the curve if the value of x is less than 2 or equal to 2 or larger than 2. So you know that if x is less than 2, your differentiation of x will be less than 2, correct? Since you know that the differentiation of y is when it is equal to 2 is equal to 0, and when differentiation of y, if x is larger than 2, definitely the differentiation of y will be more than 0. 0. Okay, in this case, as you can see from this diagram, so from these definitions of the gradient, you know that a negative gradient where dy over dx is less than 0 will give you a curve like this. Okay, and if dy over dx is larger than 0, you have a curve like this. So, and when dy over dx is equal to 0, it is a straight line. Okay, I'm sorry if it looks tedious. So if you can see from this, you know that the curve would be somewhat like this, correct? Where you have tangent here and here and a straight line. So 2, 3 is actually a minimum point. Thus the turning points of the quadratic curve is a minimum point.